Okay. Thank you so much. Okay. All right, so today's a part 2 of yesterday's lesson. We're going to look at situational domain. So that means looking at problems in context. We're also going to start word problems, everybody's favorite thing. Yeah. Okay, so first off, just a really quick review. If your Q value is 0, how many x-intercepts would you have? Your Q value, ooh, somebody said it. 1. Okay, it means that your vertex, hey, go away. Your vertex, right, is x comma 0. So some x value, it's on the x-axis somewhere. So if your vertex is on the x-axis, it's either going to open up and or down, it doesn't matter. It's going to have 1 x-intercept. Okay, the next guy. I'm going to make this a lot larger, make it easier to draw. If Q is greater than 0 and A is greater than 0. Okay, so if Q is greater than 0, that means the vertex is above the x-axis or below. Your vertex is above the x-axis, and this graph is going to open. So vertex above, and it opens up, meaning we would have no x-intercepts. If Q is greater than 0, so that means vertex is above or below the x-axis? Above, opening, what direction? Down. So above, vertex above, opens down. Meaning you'd have to have 2 x-intercepts. So math teachers love these type of questions where it's very abstract. You have to understand the formula, right? We love questions like that. And you have to really think your way through it. Okay, this time Q is less than 0. So that means your vertex is where? Below. And it opens up. How many would you have? 2. 2 x-intercepts. And last, Q is less than 0. So below, somewhere below. And it opens down. So therefore, none. So it turns out that if A and Q are the same sign, there's no x-intercepts. If they're opposite signs, they're going to be 2 x-intercepts. And if Q is 0, 1. So I'm going to zoom back to normal. So we're going to look at situational domain and range. So we're going to look at what's a context. So we have to remember things like time cannot be negative, right? If you're dealing with objects, they have to be like number of jelly beans can only be whole numbers, things like that, right? Height usually can't be negative, depending on the situation. So grab your graphing calculators. Let's take our equation in standard form and relate it to an actual problem. So you're going to need your graphing calculator. Whenever something's in standard form, well, not whenever, because you're going to learn tomorrow how to change standard form into vertex form without a graphing calculator. So I know, crazy, right? It's amazing. Okay, where were we? Calculator. Graph that. Plug it in. Then let's talk about the context after. No, I want to move my calculator. There you go. Hey. Move my calculator. There we go. Oh, did I turn this on? Nope. Better. Okay. Come on. Y equals negative 4.9. Does that look like a formula you've seen before? Kind of? If you're taking physics? 4.9 is probably approximately half of acceleration, right? Due to gravity. 5.5x plus 12. So this situation is a diver. A diver dives off a diving board. It's really important that that you read the rest, okay? So that you understand the variables. Her height is meters above the water. So we're only looking at height above the water, and the time is in seconds. Okay, so we're graphing height versus time, but height of the diver above the water. What is the maximum height? How do I get the maximum height? What's that called? What do I have to look at? First off, can you even see it on here? No, so we need to change our windows. Specifically, what part of our windows? X or Y? Y, we need to go higher or lower? Higher. So Y max, what do you want to make it to? 50? It was like only a little bit was missing. 20? Okay, let's do 20. I mean, you could do 50, but then your grass is going to look like so skinny. Or like you're going to have so much extra. Is 20 enough? I think 20 is enough. Because think about it. Our y-intercept was 12, right? So, okay, that's good. So let's find the maximum height. How do I find that? Yeah, the vertex. So second, trace, 4, left, enter, right side, enter, and then you could just push enter for your guess to get the same thing. The 2 decimal places. Your vertex right now is 0.56 and 13.54. So which one answers the question, what is the maximum height? Yeah, 13.54. It's the y value. So when we're talking about a maximum or a minimum, we want the y value. Now, if this is a context, I need units. 13.54 meters. Okay, what time does the maximum occur? 0.56 seconds. So that would be the x value of the vertex. What is the height of the diving board? What are they really asking for here? The height of the diving board. Height of the board. Not the same as the vertex. Same as something. Sky, do you think you know what it is? Oh, I thought you had. The height of the diving board. Yeah? Idea? Not the first x-intercept. The h-intercept. Yeah, the y-intercept. Yeah, the h-intercept, the y. It's where we begin, right? At time 0, is the diver on the board? Yeah. So we want the h-intercept or the y-intercept. Okay. So that would be, do we even have to use our calculator to get that? No, because it's the c value. Remember, the c value is also the y-intercept. So 12 what? Meters. At what time does the diver hit the water? What time does a diver hit the water? So, x-intercept, or the t-intercept, right? Do we want both of them? No. Why? What does this time even exist over here? No, because you can't have negative time. So technically this graph doesn't even begin till x equals 0, right? Because you don't have negative time. So we want just this guy over here. That's the one we want. So second trace, what number would it be? No, 2. Intersect, intercept. I know it sounds like the same. So 0 is another name for an x-intercept. And you have to go left bound. So left side of it, push enter. And then on the right side of it, enter. And the guess, you could just push enter. It doesn't matter. Okay, so it's 2 decimal places. When does he hit the water? 2.22 seconds. How high did the diver get above the board? Above the diving board? Well, his maximum height, he went to 13.54. Where did he start? Where is the board? at 12. So if the board is at 12, and then he jumps and he gets to 13.54, how would I get how high above the board? It'd be 1.54. We would subtract the two. His maximum height minus the height of the board, which is 1.54 meters. Okay, so let's talk about the domain for this situation. If it was just the graph and there was no context, it wasn't about a diver, it would be XER. But this time, the domain has to do with a context. So if we think of our x values are actually what variable? Height or time? Time. So time exists between what two values? 0 and when? Okay, well, can you have negative time? No. Can you have negative height in this context? No, because we're graphing just the height above the water. So once you hit the negative values, that's height below the water. We're only looking, so really what we're looking for is just, we want these to start at 0 window. So x starts at 0 and y starts at 0. So let's change our windows a little bit for a second. Okay, x and y should only be starting at 0. So this is actually the only portion of the graph that we're really looking at. The rest is not important to us. It's not in this context. So the domain is from 0 to what? Our x-intercept, 2.22 seconds. Notice how I put time instead of x in there, because the equation had time, not x. So your range for your height is between what two values? Okay, so the highest would be 13.54, your max value. The lowest height you could be 0. So you start at 12, but you end at a height of 0, right? So big mistake with students will make in this is they'll put their y-intercept. I see it all the time at cash. So we start at, yes, you're starting at 12 right here, and then you jump, get 13.5.4, but then your height decreases until you get to 0. So the height is actually between your lowest height, which is 0, and your highest height, 13.54. The graph is between those two values, okay? Got it? Because that's going to be a test question for sure, something like that. Got to understand how to write domain and range when it's a situation. And it's not just a graph, it's a standard graph. Okay. Ooh, I like these ones. Don't you love when I say that? That's when you should star the question. A lifeguard at a beach has 200 feet of rope to section off a rectangular swimming area along the beach. I so would love to be at the beach right now. Write an equation to represent the area of water that a rope can create. So we want an equation specifically relating to what? We said write an equation to represent what? Area. The area of water. And the shape that we're dealing with is a rectangle. So this should be an easy formula, right? What's the area formula for a rectangle? Length times width. Now here's the problem. Could I plug that into my graphing calculator? No. Why? Right now, how many unknowns do we have? All of them, 3, right? In your graphing calculator, our functions are for how many unknowns? 2, a y and an x, right? We're relating y with x. So we need to make this an equation with only 2 variables. So is there a way to do that? Do they give us some other information about this rectangle? There's 200 feet of rope. Now, are you putting rope? So here's the beach. Maybe this is your little umbrella. Little person. Just daydreaming a little bit for a second. Okay, there's the beach. Are you going to put the rope in front of the beach here? Would you put a rope there? Have you gone swimming at a beach before and it's been roped off? We need to get to more beaches, clearly. Okay, you do not put a beach along the sand, your entrance, right? It's just going to go on the sides, and then they're out here. So that would be the rope. It would be a rectangle, unlike the shape that I drew, but it would look like that. You wouldn't put a rope along your entrance. It'd be just roping off that portion. So how many widths do we have? 2 widths. How many lengths? 1 length. Okay, and we want all of that to equal how much? 200 feet. So 2 widths plus 1 length equals 200. So they give us this extra information because now we can actually somehow replace that, do some substitution into the other formula. Who's easier to arrange for? Length or width? To get by itself. L or W? L. Definitely L because his coefficient's 1. How do we get L by itself? Minus both sides, 2W to both sides. So let's move the 2W to the other side by subtracting it. Just subtracted 2W to both sides is what we did. Right? So now, can we change our area formula? What can we do in this area formula instead? Okay, let's replace L. We know what L is equal to. L is equal to 200 minus 2W. So let's replace our L with 200 minus 2W. Now do we have an equation with just 2 variables? Yay! Oh, I don't know why I wrote minus L or minus W at the end there. It's length times width. Sometimes my brain. All right, we could simplify this if we want. How would I simplify this? The rainbow? I like that. The rainbow? Also known as distributive property, but the rainbow is a nicer name. So distribute the W in and we get 200W minus 2W squared. W times W is W squared. So there's our formula. Could we punch that in our calculator now? Yeah, let's do it. Our windows might be a little messed up, but we can play with them later. Start with clearing what we have there. Now obviously I'm not going to put W, I'm going to use X. So X will represent width, Y will represent area. And so 200X minus 2X squared. Good. And these windows are not good. So if you might want to start with Zoom 6 to reset it, but I don't think that's going to fix anything. It doesn't. Because we're dealing with a Y variable that's area, and we're dealing with a width. And the width, what's the maximum width this could be? Almost. If we have 200 feet of rope, basically 100, really close to 100. You can almost have like this is nothing, and these is 100 each. So you know your X, if you think about it, okay, our X variable can go as high as 100. Can you have negative width? No. Honey, you're saucy today, Akash. Okay, your area, so we're graphing area now. So area, the units for area are a lot larger because you're going length times the width. Right? So if, say this was 50, 50, and 100, right? 50, 50, and 100, what would the area be then? What would the area be if it was 50, 50, and 100? I'm trying to make the largest area I could. It would be 5,000. So let's do 6,000. See if that's large enough. Okay, so notice the area units are going to be a lot larger. So 0 to, let's try 6,000 and see if that's high enough. And I'm going to go up by 100, every 100. Okay, so everyone got that down? So we did 0 to 100, scale of 10, And with y, we did 0 to 6,000. Was that high enough? Scale of 100. Did you graph it? That's high enough. Probably could have done 5,000. All right. That's beautiful. Couldn't have done it better myself. Okay, what does the vertex represent? So first of all, let's find the vertex. Did you find it yet? No? Second trace. Max or min? Max. Left side, enter. Right side, enter, and then guess. Did you get 50 and 5,000? Look at that, I actually drew the solution. Okay, 50 and 5,000. So what did the x variable represent? What was the x variable? The width. So a width of 50 meters. And what did the y variable represent? Max area. Because this is the vertex, right? Gives max area of 5,000 meters squared. Oh, feet. Sorry, feet squared. Feet, not meters. Wrong unit. So used to metric. So when I ask you on a test, what does this represent? That's what I'm looking for. I want you to describe in the context. I'm not looking for what does the vertex represent? Oh, it's the highest point of a graph. No, I know that. So it's in the context of the question. So if you have a contextualized problem and I'm asking you what it represents, we mean in this context. Okay? Because that also is a popular question on a test. What is the domain and range? So we had area and width. Okay? 0 to, what was the y other x-intercept? It was 100. Did you notice that our windows were 0 to 100 for x, and it actually landed exactly on the 100? And then our graph, what was the maximum height? What was that? Or maximum area, sorry. It was 5,000, okay? So the domain, let's talk about this really quickly. Domain, which variable am I going to use? Instead of x, w. Don't write in your inequalities just yet. So your width is going to be between what two values? Let's put the numbers in. 0 and 100. Now, can it be equal to 0? If our width was 0, would a rectangle exist? No. If the width was 100, would the rectangle exist? If you had 100 and 100, and you have 200 feet of rope, would it actually form a rectangle? No, because there's no dimension for the length. So it's between 0 and 100, but not including 0 and 100, because if we include those dimensions, it actually would it would just be a line. That's it. Okay, range, which is area, is between 0 and 5,000. Now, can your area be 0 and it still be a rectangle? No, that means one of your dimensions was 0, therefore it wasn't a rectangle. So it can't be equal to 0, but it's greater than 0. Can it be equal to 5,000, your maximum? Yes. So that's where the only inequality goes, or the only equal to symbol goes. Okay? A couple of assumptions. We made a couple assumptions here. One assumption is we're going to use all the rope. Okay, you might not actually use all the rope, right? But that's one assumption, right, Akash? Okay, another assumption is all widths are available. So what I mean by that is that in a real life context, you might want to avoid rocks, or maybe you want to avoid a deep area. So you might actually not use that maximum area. It might not actually make sense to have a dimension of 50 by 100 because maybe you want it to be longer and a little bit more shallow. Depends on, or do you really want it to go very deep, right? So in real life, depends, I don't know, it depends on the actual geographic situation you have. Okay, one more area problem. And then I'm debating whether we're going to skip the last one. We might go through that another day. Okay? The farmer has 1,000 meters of fencing and wishes to build a series of rectangular holding pens. So there are 4 equal pens as shown. One for your pigs, one for your cows. Anyways, write a function for the area of the enclosed area. Okay, anyways. Sorry. Great vocabulary, Johnson. Great sentence structure. Okay, so we want an equation for area. What is the usual equation for area? What shape is this? The big shape. A rectangle. And area is length times width. Okay. Problem. Is there a problem there? Yes. Too many variables. We need to get rid of one. So here we have the length of our pen. Because did they say they're evenly spaced? No, so we don't know if they're evenly spaced. We can't assume that those are the same. Oh, well then actually we can. You're right. 4 equal pens. So then you could. You're right. So there's a few ways we're gonna actually, because we want area is length times width. So keep it simple. Instead of having 4 of them, 4 lengths, we're just gonna make it 1 long length. And 1 width. Okay, how much fencing do we have? 1,000 meters. So 1,000 equals, how many lengths do you have? 2 lengths, right? 1, 2. One on top, one on the bottom. How many widths do you have? 1, 2, 3, 4, 5. There's 5 because you actually have to start and finish. 5 lengths. Or sorry, 5 widths. Who do you want to solve for? Length or width? Get width by itself? Length by itself? Sure. Okay. Let's get length by itself. So first step. Minus 5W. And then divide by 2. So instead of dividing this whole thing by 2, I'm just going to divide each of them everybody individually by 2. It makes the equation a lot easier to solve. Okay? A lot easier. Because, can you simplify one of those? Yeah. 1,000 divided by 2, 500. Minus 5 over 2W, so we'll leave that as a fraction, equals L. Okay, so now what are you going to do? Replace what variable? Replace L with 500. L equals 500 minus 5 over 2W. So let's replace it. 500 minus 5 over 2W times W. Length times width, and length is 500 minus 5 over 2W. 4, expand that. 500, do the rainbow. W minus 5 over 2w squared. Okay, what I'd like you to do is graph this in your calculator and come up with the windows yourself. That's the fun part. You kind of can work it through your, work it out. There's 1,000 meters of fencing. It's kind of the maximum widths you can have. So you might have to play around with your windows. I'm going to give you a minute. Minus 5 over 2. Oh, no, sorry. I missed an x. 500x minus 5 over 2x squared. Windows 0 to 200. Scale of 10. And y from 0 to 500,000. Is that what I said? Scale of 10,000. Graph. Oh, that's too high. I added, it's 50,000, yes. I added an extra few zeros, one extra zero. So then a scale of 1,000. Let's take away 1 0. I multiplied wrong. Better? Still too big? Okay, so then what would it be? 100. If their widths are 100, your widths are 1, 2, 3, 4, 5. 100 times 5. 100 times 500. Isn't that 50,000? It's 25,000? Oh, because there's 2 lengths. I'm adding it wrong. There's 2 lengths, right? So it's 250 each, Johnson. Yes, there's 500 left, but there's 2 lengths, one 250, one 250. So that's why it's actually 250 times 100 should be our dimensions. So 25,000 is even better. As long as I can see your maximum, that's all that matters. Okay, graph. That should be perfect now. Can't get better than that. Okay, so let's write our windows out. So the windows were, for x, 0 to 200, scale of 10, and y, 0 to 25,000, scale of 1,000. Okay. What's your vertex going to be? Where's your vertex at? I mean, once you get your windows, if you get your windows perfect, you don't even have to use your graphing calculator and use the maximum feature. We already said, right? It's at 125,000. 125,000. So here our graph looked like. Here's area, here's width, and it went from 0 to 200 and 0 to 25,000. So the vertex was at 100 and 25,000. So in the context, what does it represent? What does the x represent? Which variable? W, so a width of 100 meters gives, what's the 25,000 represent? What variable? Area. And that's specifically what about the area? The max area of 25,000. If they ask for the dimensions, you need to figure out your length as well, right? So domain is between what two values? 0 and 200. Would you include, would it be an equal to sign or just greater than? can you have a width of 0 and still have a rectangle? No. If the widths were 200, would there be anything left for the length? No, so it's just between 0 and 200. Your area is between 0 and 25,000. If your area was 0, is it a rectangle? No. So just greater than. Can it equal 25,000? Yes, that's the maximum. Okay, so that would be your domain and range. Alrighty. So the next question, we've done many like this already. I'm going to skip it and maybe come back to it. We'll come back later because it's just another one of those ones like we did yesterday where we put the x and y axis wherever we want and we make the equation solve for the a value. So it's not as much for today's lesson as more of just a review, and we're kind of short on time. So at this point, for those of you who've been here, you need to start the homework, and the homework is on page 174 to 179, numbers 7 to 10, 12, 15, and 17. Okay, so if you want to grab your textbooks. For those of you who just walked in, I'll start pulling up the notes so you can start writing them down. Okay? I'm just going to stop this.